Welcome back to class. And in our lecture now, we want to look at limits of exponential functions. So to begin with, we want to start with the first exponential function that we call the natural exponential function. So we say let's consider the graph of the function f of x is equals to e raised to the power x. Now let's graph this function f of x is equals to e raised to the power x, and we observe the behavior of the graph. What happens if x takes on numbers that are leaving from like 0 going to negative infinity? And what happens to the graph when x takes on number from 0 leaving to positive infinity? So we want to study the behavior of the graph. So we have our table like this, and we say let x be few numbers. So we say let x be 0, let x be 1, let x be 2. Now we try some negative numbers. So we say let x be negative 1, let x be negative 2. So each of these numbers, we put them within this function. So we say f of x now is equal to e raised to the power x. What if x is 0? Y will be what? Now mind you, the function f of x can also be written as y equals to e raised to the power x, right? Because y is also the name of a function, f of x is also the name of a function. So if you have y now equals to e raised to the power 0, anything raised to the power 0 is just equals to 1. So our y will be 1. What if we have x to be 1? So we say y equals, when x is 1, you have e raised to the power 1, it just equals to 2.71. We just take 2.7 approximately. What if we say x is equals to 2? So we have y equals to e raised to the power 2. Now, so it's like saying 2.7 times 2.7. So we will get something around 7.4, approximately 7.4. So what if we have y taking on some negative numbers? When, let's say x taking on some negative numbers. If you have e raised to the power minus 1. Now, whenever the exponent of a particular expression is negative, the first thing you do is to reciprocate, thereby making the exponent positive. So we have 1 all over e raised to the power positive 1. So now, if 1 is being divided by e raised to the power positive 1, we will just get, okay, now this is 7.4. So if 1 is divided by e raised to the power positive 1, we'll get approximately 0.4. As x takes on minus 2, so y equals minus 2. So again, we reciprocate to make the power positive. We have 1 all over e raised to the power positive 2. So if we do that, thereby bringing in the value for e and squaring it, we're going to get approximately 0.1. So now, let's graph this thing and observe the function. But now, before we put these points within the graph, we can clearly see that as x leaves from 0 going to positive numbers in the positive direction, as x leaves from 0 to 1, 0 it was 1, it left, it went to positive 1, it became 2.7, it went to positive 2, it became 7.4. So as it is increasing in the positive direction, the entire function now is also increasing. Now, let's ignore this positive portion and let's consider from 0 now to these negative values. As x takes on 0, you have positive 1. So y is equal to positive 1. As x takes on minus 1, you have, from positive 1, you have 0.4. So it is reducing. As x takes on negative 2, it goes to 0.1. So it is reducing. So let's plot these points first, then we can, so I'm erasing this one. So we have a graph like this. So we got this 1, 1, 2, 3. 1, 2, 3. Got this 1, 2, 3. Got this 1, 2, 3. Got this 1, 2, 3. 1, 2, and 3. So these are y-axis and these are our x-axis. So this point is the origin. So let's plot these points now. When x is 0, now mind you, this area is 0, 1. When x is 0, y is 1. This one is 1, 2.7. This one is 2, 7.4. This one is minus 1, 0.4. This is minus 2, 0.1. So when x is 0, this point 0, y is 1. So you have, when x is 0, you move in the y direction 1 unit. So we have 1 right here. So 1 is right here. The next one, when x is 1, we have y to be 2.7. So when x is 1, we have y to be 2.7. So when x is 1 now, y to be 2.7. So 2.7 is between here, assuming that this is 2.5. So 2.6, 2.7, 2.8, 2.9. So let's say 2.7 right here. So let's consider this to be 2.7. When x is 2, this is 2. Now y is 7.4. So you understand that it's going to be all the way up, right? Okay. When x is minus 1, when x is minus 1, y is 0.4. So consider that this between here is 0.5. So 0.4 is somewhere around here, for example. So when x is 1, y is 0.4. So somewhere around here, approximately. When x is minus 2, y is 0.1. When x is minus 2, y is 0.1. So 0.1, assuming it's somewhere around here. So as you continue in the negative direction, so this means that as x is approaching negative infinitive, so as x is taking on numbers in this direction, what happens to our function? Our function now will be approaching 0. So we can write that in a limit form as saying the limit of the function e raised to the power x as x is approaching negative infinitive. This entire function now will be equal to 0. Because you see it left from positive, positive 0.4 to 0.1, and next one might be to 0.0 something. It's just going to be approaching 0. So just say it's equal to 0, right? Now, for this case also, as x is approaching some positive infinity, what happens? We say when x is equal to 1, positive 1, you have y to be 2.7. When x is positive 1, y is 2.7, is going up. We did not see that when x is positive 1, we have y to be negative 2.7. No. It went up, right? When x is positive 2, y is 7.4. So it went upward portion. It went all the way up. So the fact that y is increasing as x takes on positive value, that's going to continue in this direction. So as x is approaching positive infinitive, the y function now is just increasing infinitely in a large direction. It's just increasing, right? So it's moving in the positive direction. So it's going to be positive infinitive. So we say the limit of the function e raised to the power x as x is approaching positive infinitive, this e raised to the power x will be equal to infinitive, some large values. So if we connect this thing like this, it continues all the way in that direction. This one will be getting closer and closer to 0. Closer and closer. So this now is what we refer to as the function f of x.